evaluate this limit. And then I will have to tell you, okay, this limit is a very good one, okay? It's a very important, after we get the result from this limit, I will let you remember the results, because this is a very standard, basic limits, okay? Yeah, so this will give us a very important conclusion, okay? Let's compute limit of sin of x over x when x approaches to 0.
So what would be a way to do this, like method 2?
There's no way to do it in a method 2. There's no radicals. Yeah, so for this problem, okay, the initial method to compute this limit is just by either graphing, okay, we don't have the software to graph it, so to solve this limit, the only method for us is method 1. We have to try those x values which are very close to 0 from both sides and then compute the limit, okay? There's no other way. From my point of view, I haven't, not yet. Yeah, no, I haven't come up with any method which is similar to method 2 to compute this. What I can do is just either graph it, and we don't use the graphing because we don't have a software in class available to us. So what I can suggest us is by using method 1 to compute limits. Okay, so how guys? Same thing as we just did from the previous problem, that x approaches to 0 from both directions, okay? From the left direction, we can get, I would just use these values because they're more, very good numbers. And then compute sin of x over x. Any questions?
When you say that using two values on either side should be enough?
Well, sometimes two values won't be able to, tell you the pattern, just like a 1/6, For this, maybe two values are enough, but for some different functions, two values may be enough, may not be enough. You won't be able to see, when x approaches to 0, what will the y value approaches to. So that's why they always keep, want to choose a lot of values so they can have a better view about why, how this y value approaches to. So usually 3 or 4 or more, okay? So as long as you can see the pattern, that's fine. Maybe two values are enough, okay? But it really depends. Okay, so you can also try when x are positive values, 0.01, 0.001, or more, okay, 0.001, okay? And then compute the sin of x over x, okay? So that's very necessary for us to use our calculator. Okay, you need to have a calculator, because what is sin of parenthesis negative 0.1 and then divide by negative 0.1. Yeah, because sin function, it is odd function, okay, and x function is also odd. So the result for these should be the same, be considered with this, okay. So you can try sin of negative 0.1 divided by negative 0.1. Have anybody get a result? Grant?
Yes, it's. How many decimal places do you want to go to?
How many digits do you have on your calculator? Keep running?
It's a sign. It's going to go on.
Okay. Can you give me like at least 5 or 6 digits at least?
For negative and
You need 9
positive.
to notice they're all 3.
Oh, 9? Okay. So as many digits as possible from
0.017453284.
0.0174
5
5
3
3
2 8 4.
8 4. Okay.
And it's the same for both positive and negative.
Yeah. Everybody get the same result? Okay. How about when x equals negative 0.01?
Can I say something? If I'm correct, this needs to be radians, not degrees. You're doing a very, very different answer in radians, which is actually...
Yeah, this is like a off.
Because if you do it in radians, you get 0.9999833, and that's more.
Yeah. So this 0.1, what did you use? Use degree, right? You use degree?
Yeah.
Well, degrees. Well, this x value should be in radians. Then, because eventually, okay, this limit will equals 1. okay? So this number is kind of away from the 1, right? So,
How should I know on any given question if it should be in degrees or radians? Or should I just always
well,
use triangles?
degree, there is a sign for degrees when x equals 6 degree. There is a symbol, this little, like a circle on the right top. If it doesn't say, it's a, if x is given by negative 0.1 or 0.1, there's no symbol about this open circle, the little circle. It is mostly in radians, you're right.
If you're not doing like triangles or shapes, that's not.
So whoever are using calculator, please change your x value in radians. Okay, do you know how to change that? Under mode, right? Under mode. Change your x value in radian, R-A-D, not a D-E-G, okay? If you're using D-E-G, you'll probably get this, but this is not 0.1 degree. It's 0.1 in radians, okay? So choose this, but not that.
It just lets me build tables.
Have you got it?
I'm very lucky with a computer that just lets me build tables.
Oh, okay.
So
There you go, man.
I can get a table of any of those values.
Okay, so it should be 0.99, right? 0.9.
Yeah.
This is also 0.9 something.
Yes. But it's all 0.9 and there's lots of 9s until it gets to...
Lots of nines.
Here, I'll get you the exact.
Okay, so give me the negative 0.1. What is the y value? 0.99. I probably need several digits.
Okay. 0.99833416.
Okay, that's enough. Okay, see, this is a 0.998. Okay, and how about if we choose x equals 0.01 or negative 0.01? We should have more nines.
4 9s.
4 nines, right? And then 8 something, right?
Yeah.
Or 8 blah blah, I don't know, okay? See, this one is more closer to 1 than this one, right? And then this one will have more nines, I don't know how many nines, 6 nines and then 8. So this one is more closer to 1, okay? So that means we can already see the pattern when x is getting more close to 0, and this value will get more close to what? To 1. Same thing here, okay? We can copy because sin of x odd divided by odd still same, okay? So 9983349999 8 blah blah, and more nines, okay? So we can see that when x approaches 0, sin of x over x will approaches to what? Approaches to 1. And we write the limit of sin of x over x when x approaches 0 equals 1. Okay? Well, in class, this is only method for us to get the results. Just keep on doing the x values. Okay? Well, here, guys, please remember this. Okay, please remember this, because we will use this conclusion for our later calculations. Okay, later if we have what is the limit of sin x over x when x approaches 0? 1. Okay, it's not 0 over 0, because very directly you can see, oh, when x approaches 0, sin of x approaches 0, and then this bottom part is also approaches 0, so 0 over 0, so undefined? No. Okay, the entire limit equals 1. Very good. What do you feel? It's okay, right, so far? Okay?
Yeah.
Alright, so this is the limit of the functions. Okay, let's look at one more example. Okay, one more example. Okay, so this example will introduce us for some more specific definitions of hand limits. Okay, hand limits. Okay. So let's compute limit of h of t when t approaches 0. H of t is a piecewise defined function. It has two pieces. Okay, one piece is when t is less than 0, h equals 0. The other piece is when t is greater than or equals 0, h equals what? 1. So, can we draw the picture for this piecewise defined function? Horizontal axis give us t values. Vertical axis give us what? The h values. T less than 0. Oh, t approaches 0 from the left. H of t equals what? 0. And how about this endpoint? Do we have to use open circle or closed circle? Open, because this is strict, okay? strict length sum, okay, open circle. So if we draw the picture, it looks like this, right? This is a one piece, okay, this is a left piece. How about the other piece? When t is greater than or equals 0, h equals what? 1.
It's equal to, so you can have it.
Yeah, here we have to use a closed circle because what? When t equals 0, h equals 1. So this is the whole picture for the Heaviside function. Okay, yeah, in the textbook you'll find this function is called a Heaviside function. Okay. Well, what is the limit of h when t approaches 0? Does it exist? Yes or no? We say this limit doesn't exist. Because in order to have an exist limit, we have to make sure that both sides of the limit, they are existing and they have to equal the same value. Okay, see, the h at the L value when t approaches 0 from the left side equals 0. How about when t approaches 0 from the right? The L value is 1. They don't equal each other. So we say this limit does not exist. And then we have some other definitions, okay? So we have our definition 2 and 3 about left hand limit and right hand limit, and also when will the limit exist, okay, involving what? Related to the left hand limit or right hand limit. I'm going to ask one volunteer to read the entire 3 paragraphs, okay? So who's turn? Dakota?
Sure. Alright. We write limit x of a minus f of x equals L. And say the left hand of f of x as x approaches a, or the limit of f of x as x approaches a from the left is equal to L if we can make the value of f of x arbitrarily close to L by taking x to be sufficiently close to a and x less than a.
Yeah.
Okay. We write limit x of a positive f for x equals L. Say the right-hand limit of f of x as x approaches a, or the limit of f of x as x approaches a from the right is equal to L if we can make the value of f of x arbitrarily close to L by taking x to be sufficiently close to a and x greater than a.
Okay, definition 3 please. Yep.
Turbo, please. Limit x approaches a, f of x equals L, if and only if both limit x of a minus f of x equals L and x of a plus f of x is equal to L.
Very good. Thanks. Okay, thanks. So from these definitions, okay, first, okay, we look at this, okay. This limit is called a left-hand limit. And then why we call it is a left-hand limit? Because this limit tells us what? When x approaches a from the left. So we use a mapping sign, okay? And you can read this. Yeah, Dakota just read the definition. I'm not going to repeat it.
So,
What's up?
So for the previous question, the left-hand limit would be 0 and the right-hand limit would be 1?
Yes, we'll go back to that. Haven't said question. Example. Very good. Okay. Left-hand limit, okay, equals L. Okay, is defined like this. Blah blah. Right-hand limit, okay, we use x approaches to a plus means this is x approaches a, but from the right. Okay, means x is greater than a, but approaches to a. Okay, so this is called a right-hand limit. Okay, when do we say the limit when x approaches a from both sides exists and equals L?
When they both equal L.
Yeah. If and only means equivalent to. Okay, equivalent to means what? In this direction, if the limit equals L when x approaches a, it will implies both kind of limit exists and then they're both equals L. Reversely, same thing. Both hand of limits exist and they both equals L will implies what? This entire limit exists and equals L. Okay, so why we say in the previous example, the Heaviside function, this limit doesn't exist. Because even if we have the both hand limits, okay, what is the left hand side limit, okay, when t approaches to 0 negative, what is it, h of t? Equals what? 0. The right hand limit is what? 1. Even if they both exist, but they do not equal each other, okay, they don't have the same value L, then we still say this entire limit does not exist. Okay, so I want you guys to really understand it, okay? It's not like, oh, if one side equals this, the other equals that, the whole limit exists. No, okay? They must both exist and equal the same value. Then the entire limit exists and equal the same value. Everybody? Okay, now guys, let's practice, okay? We have activities, okay? This is actually homework, well, not homework assignment, this is a practice question from the book. I hope you guys can see it, okay? This is a function A, the graph of the function A. Answer these questions A, B, C, and D. I hope you guys can see it, okay? I hope so. I'll give you a couple minutes to think about it. The first question is, what is the limit of A when x approaches to -3? This is when x approaches 2 from the left, x approaches 2 from the right, and x approaches to -1. And number 8 is the equation of the vertical asymptotes. We'll talk about asymptote later, okay, in class, okay? But we can also mention the answer for this question. Some of you guys answer the question, okay? So let me see. John? Can you answer question A and B, please? X approaches -3, what is the value for y? Does it go to any specific value L? No. However, because the y value will be very, very large infinitely, right? So we say, oh, this limit equals infinity, okay? Yeah, we use this symbol because y does not approaches to any specific value. Y goes to what? Infinity large, okay? We don't know how large it is, but it's going to be huge, very, very large, so we use infinity, okay? Same thing. Similarly, question B. John? When x approaches to 2 from the left, which is this, what is the y value approaches to? -infinity, right? Everybody agree with him? Very good, thanks. Okay, so this is a graph, okay, this is a graph, okay, this is a graph. Well, we can tell, you see all of these, the point on the graph, there are many infinite points, okay? So when the x value approaches 2 from the left, the y value goes to -infinity, okay? All right, I'm going to ask another. Dylan? Oh, okay, so when x approaches 2 from the right, A approaches to infinity, right? How about D? Where's -1? Here? -infinity, right? Yeah, from this one doesn't say from left or right. That means from both sides, okay, both direction, okay, both direction. And from both direction of the -1, we can tell the y value goes to what? -infinity. Are you guys okay? Yeah. So we will introduce the definition of involving infinity on the next page. But this is a preview question. You guys good for these ABCD questions? Okay. All right. The equations of the vertical asymptotes. Yeah. Vertical asymptotes. So do you see these vertical lines? Okay. See, one vertical line is when x approaches -3 from both sides, oh, the y values go to infinity, okay? So this vertical line has equation x equals 3. This is the vertical asymptotes. Yeah. Okay, cannot be -3. Okay, x cannot be -3, sorry. -3. Oh, let me rewrite this. This is one vertical line. Can you see the other vertical lines? Yeah. And you see, our graph will be very close to this vertical line but never touch, okay? See, this one is when x approaches to -1 from both sides, okay? Y value goes to what? Negative infinity, okay? So it doesn't matter y goes to infinity or negative infinity, okay? Either way, this vertical line, it has equation x equals -1. This is another vertical asymptotes. And then do we have more? X equals what? This is when x equals 1 and 2, right? 1 and 2, okay? Do we have more? No more, okay? So how many vertical asymptotes from the graph? 3 of them. X equals -3, x equals -1, x equals 2, okay? So we'll talk about these on the next page, okay? All right, our next example. This is like you have to, think about it, okay? Sketch the graph of the example of a function that satisfies all of these given conditions. Your graph may not exactly equal, the same as the other student, okay? Everyone has their own graph. However, your graph, your function f, must satisfy these conditions. So, function f of x, so independent variable is x, dependent variable is y, which is f of x. 1, 2, 3, 4, 5, 6 conditions. I'll give you a hint for the first two, and then you can mimic and do the rest, okay? Limit of f of x when x approaches to 0 negative equals 1. How can we draw this limit on the graph? Grant?
A line approaching from the left to the point 1.
Yeah, this limit is telling us when x value is approaching 0 from the left, y value will be close to what? 1. Okay, so that means we don't care what what is on the left when x is less, on the left and when x is less than 0. But we know when x approaches to 0 from the left, okay, y will approaches to 1. Well, here, how about these endpoint? Can we use closed circle or or open circle?
So at the very end, it says f of 0 is undefined.
Okay,
So
f of 0 is
we have to have open.
Yeah, it really depends, okay? Depends. It says alpha 0 is undefined, so if we use a closed circle here, means f of 0 exists, okay? Maybe, equals 1, or this is value 1, or maybe different value, but so far we don't know, so we use an open circle right now. We might change in the later, depends on the question, okay? Also, guys, do you see the right-hand limit? Right-hand limit is equals 1. This right-hand limit is telling us when x approaches 0 from the top or from the right, the y value approaches to what? -1. Your y value may be close, approaches 1 from below and or from above. It depends. We don't know yet. Okay, we don't know yet. However, we know when x approaches to 2, from the left, y value goes to what? 0. Okay, when x goes to 2 from the left, y goes to 0. So we might make our graph look like, between the, when y equals 0 and y equals -1. Okay. So how about the endpoint here? Do we use open circle or closed circle?
You have to have it open.
Yeah, we may keep it open, okay? We'll see, okay? So far open circle is safe, okay? But we'll see whether we need to change this or not, okay? So leave it open and we check. How about x goes to 2 from the left? Open circle, it doesn't say f of 2 equals 0, so we just use open, right? And x goes to 2 from the right, f of x goes to what? 1. Oh, we don't know, right? So your graph function may go down or may go up. So everybody, you may have a different graph, okay?
And how about f of 2? Does f of 2 equals 1?
Yes.
So this will become a closed circle because f of 2 exactly equals 1, right?
And then it says f of 0 is undefined.
The circles remain open.
Yeah. So because it is f of 0 is undefined, we may leave both of these two endpoint open circle, or you may close one of these two. Well, f of 0 is still, no. F of 0 is undefined means there's no steps value for f of 0, right? So we leave both of these two endpoint open, okay? If it says f of 0 is defined, means what? Yeah, so on this vertical line, this y-axis, there must be a close the box, close the point for f of 0. Because f of 0 is undefined, we make sure there's no closed point on this y-axis. See, my graph looks like this. Your graph maybe looks slightly different, but yeah.
Does that mean that at x equals 2, the limit doesn't exist because both of them?
Yeah. Well, because the left-hand limit and the right-hand limit doesn't exist, doesn't equal each other. So we know when x approaches 2, f of x does not exist. However, the limit of f of x when x approaches 2 does not exist is different from f is defined or not. So this f of 2 equals 1 means f is defined at x equals 2. But the limit doesn't exist because the two-hand limit doesn't equal each other. So even if the limit doesn't exist, when x equals 2, this function may be still defined, okay? However, the limit, we only care about when x approaches 2 from both sides. These two, the y values, they don't equal each other, right? One goes to 0, the other goes to 1. So because of the two-hand limit doesn't equal each other, so this limit doesn't exist. But f of 2 still defined at 2, okay, when x equals 2. Guys, another question for you. How about the limit of f of x when x approaches to 0? From both sides. Is that limit exist or no? Yes or no? No, because the both hand limit, even if they both exist, but they don't equal the same value, so we say limit when x approaches 0 from both sides, f of x, this limit is also does not exist. Because if there's no sign, negative or plus, that means x goes to 0 from both sides. If there's a sign, either negative or positive, it's just a one-side limit, okay? And in order to make this entire limit exist from both sides, we have to make sure both side limits exist and equals each other, okay? Otherwise, this limit will not exist. Can we move on, guys?